Okay, we're gonna get started now. Are you all gonna stay up here?
No.
And take my space?
Yeah. I'll help them if you want.
Take space. Yeah. Okay, so welcome. Thanks for coming to our game workshop. Yay.
Make some noise.
What is this, Mercer's class?
Okay, so my name is Livio. I'm going to be teaching the workshop. And this workshop is put together by the GameDev Club. There's our website over there. As you can see, we're recording this, so you'll be able to find a full recording of it online. Pretty high quality stuff. So for this workshop, it's intended for, it's intro to game programming. So we're going to teach you how the basics of how to program a game using a regular programming language like Java. We're going to be using Java, and we're going to be using Eclipse, and hopefully all of you should have Eclipse on your computers. Okay, so this workshop, we're going to cover some things that are probably going to be pretty confusing if you haven't taken object-oriented programming yet. But you should still be able to follow along. We're just going to show you how to do some things. You might not be able to really understand why certain things have to be done in certain ways. Most of the time, the answer to why is going to be because Java makes us do this way. So that's one of the limitations of working in Java. So the general structure of the workshop, we're going to start by, we're just going to make a game where if you follow along, we'll make the same game all together. And then maybe at the end, we'll give you guys a chance to just play around with what you've made and make it different or make it better. We're going to be making a type of game. So if this is our screen, the game that we're making is very simple. We're just going to have a circle, and this circle is going to be the player. And the player is going to be able to move the character around up, down, left, right, or on the screen. And then there's going to be like an enemy circle. And if the goal of the game is that the circle is going to be chasing you and you need to dodge him, and if you let him collide with you or if you let him touch you, then you die. That's what we're making. Very simple stuff.
Sounds so exciting.
Super exciting. It's actually more exciting than you could ever imagine.
G-O-T-Y.
But yeah, it's good that we start basic because we don't want to get caught up in all the complexities of making a big game. We just want to know, can we make a game in the first place? So the first thing that we're going to do, we're going to approach this from a very natural point of view. So when you take a programming class in the CS department, until you get to object-oriented programming, most of the time, they'll teach you how to make programs that run on a command line. So programs that basically run in the background, you give it some text, and it spits out more text at you. So if we want to make a game, the question is, how do we make something that actually is visual? How do we make a game that's actually a window on your computer and shows images to you? And that's where we're going to start. How do we make a program that does that?
Is this a question, or are you explaining?
I'm going to explain it,
Okay,
but
never mind.
you could answer my question if you want.
GUI.
GUIs, yeah. So there's a term, GUI, also known as GUI. It stands for Graphical User Interfaces. That's just a programming term to refer to anything that's graphics-based, or at least like the windows that we're going to make. So in Java, if you want to make, I'm going to draw some pictures up and then I'll show you some code. But in Java, if you want to make a window, you use this object that's built into the Java class, which is called right here, a Jframe. And this frame is basically the border of your window. It has the ability to close, the ability to maximize, and to minimize. It also has your title here, title. And that's what the Jframe is. Once we create our Jframe, we're gonna create something in here, which is the actual content. And this in Java is called JPanel. They broke up these two things into two different classes just to help you organize the code, because the Jframe's responsibility is only to be your window, while the JPanel is the content in that window. And so that's why we're going to break things up. So we're in Eclipse, and we do not have a game, so I'm going to close this. So I'm going to let's start a new project, new Java project. And let's call this something fun, like workshop game.
Fun!
Fun workshop game. This doesn't really matter. I just want to. No, I'll use 1.6. It's gonna be my workshop. Finish. So now that we have a project, let's create a class, and we're gonna create our Jframe. So I'm gonna call this. What should I call it?
My awesome Jframe.
Let's call it the name of our game. So the name of our game is Dodge the Thing. Thing. We could make. Okay, Dodge the Thing. And this is gonna. No, I'll just leave that alone. So now we have our class, and it's got nothing in it. So we are making this an extension of Jframe. We want to create a Jframe. So extends Jframe. And what this does, it will, first we have to import it. So basically we have to write this code to import the javax.swing.jframe. And what we're making is a class that extends it. That means that we're basically making our own Jframe. It's going to have all the code that the Jframe class has, but it's going to have more now. It's going to be an extension of it. Isn't that cool? Woo. So now, in order to create our program, this is just something that the way Java works. You need to create a public, static, void, main method that takes in a string array.
Yeah, string array args.
Okay, so what this method is, this is our program's point of entry. It's the first code that's going to get run when we launch our program. And what we want to do, this is we can pretend that it's running outside of this class in a way, because it's not really going to create a new instance of the Dodge the Thing class. So we're going to have to create our own instance of it. Dodge the Thing game equals new Dodge the Thing. And this is just how Java works. So if you're confused, blame the people who made Java.
I will.
So now we're making the constructor, the thing. So this constructor, this is the code that's going to get run when we create a new instance of Dodge the Thing. And what do we want to do when we create this new instance? Well, first, we want to, there are a bunch of methods that we need to call to kind of specify what our Jframe will look like. So if we do this dot set size, this will actually set the size of our window. So we can set our size to like 600 by 400. Now we have a size. We could also set our title, the title of the window. Dodge the Thing. This is the title that's going to be at the top of the window bar. That basically tells you what's inside this window. A really important thing that we have to do. Important stuff. I'm going to document my code. So set Jframe properties and stuff.
Very descriptive.
This is important stuff. So the important stuff, we need to set visible to true. Otherwise our window is going to be invisible by default. Isn't that really weird? Yeah. We also have to do something, I forget what it's called, set default close operation to, I forgot.
Exit on close.
Exit on close. Okay. Is it under Jframe?
No.
Yes, it is. So what this line does, it's basically saying when somebody closes our window, let's kill the program. Let's make it sure that it's not running anymore. Because otherwise Java will leave the program running in the background even though there's nothing to run. That's also really confusing. But this is actually a really useful thing, because what if you're making a program that has several windows? If you close one window, you don't want your entire program to crash. So this is basically saying that this is our main window. So if you close it, close everything. Quit the program. So now let's actually run this. Let's see what we've got so far. It's working. Yeah.
Good job, Livio.
Dodge the Thing. And it's a
Can you move your
600
box
by,
so people can?
Yes. This this box?
Yeah, move it so that people can see your code.
Oh, good idea.
Because people are following along.
So I'm gonna close this. Another thing we could do, we could set the location, which means right now when we run our program, the window is created at the top left. And I don't want that because it's gonna be very annoying for demos. So I'm gonna set the location to, let's do 500, yeah, 500 by 500. And see what that looks like. So I'm gonna use a keyboard shortcut to run it again. There it is, it's in the center. It's not up there, it's here. That's good. So these are just comments. You don't really need to write them, but they're useful if you're wondering what the code's doing. So we created our Jframe. We created the frame that the window is in. But if we want to actually put something inside of it, we need to create a JPanel. Kind of like what I explained behind the screen on the board. So I'm gonna, since we're creating our, here we created our custom version of Jframe. Now we're gonna create our custom version of JPanel. So let's create a new class. Go to new class. And let's, since we're gonna use this panel to draw things to the screen, let's call it a canvas. So in computer science or computer graphics, we usually say draw to the screen when we're referring to putting anything on the screen, like putting images or anything else. So we're calling our canvas, we're calling our JPanel canvas. We're gonna make it extend JPanel. And then Eclipse is gonna say, you didn't import JPanel. Let me import it for you. Okay. And that's, we basically need to write this import code. Right. And now we're gonna create our constructor right away. Public canvas. And what this code is gonna run when we create our canvas. When someone calls a new instance of it, this code is gonna run. And what exactly do we need to run? Well, I don't really know yet, so I'm gonna move on. The important part about canvas is that we need to override the paint component method, the public, oh, I forgot what this method was. The void paint component. It takes in a graphics G object. Does it return that? Let's see. I need to import graphics. So we need to write this line of code as well to import AWT graphics. And it's not complaining yet, which means I probably got it wrong. So I'm gonna, this paint component void. Maybe that is it. So this is just in order to take over the JPanel's ability to draw things, we need to basically write this method. It's gonna completely replace the method that JPanel has. So JPanel has a method by exactly the same name and the same number of arguments. And what we're doing, we're gonna overwrite it. We're gonna replace it because we want to draw our own stuff to it. An important thing when doing this, we need to call the old paint component. Even though we're replacing it, we need to be able to still let Java do the important things that it does in the background. Paint, super important. Cool, so now we have our canvas. So I'm gonna move on. So now that we created our canvas, we can add it to our Jframe. And the way we do that is we need to add it before we make our thing visible. Otherwise the JPanel might be invisible as well. So let's add our JPanel. So canvas equals new canvas. And now the method is just add canvas. And that's it. Oops. So now we basically added our JPanel to our frame. So let's try running it. It looks the same. And that's because our JPanel, our canvas, it looks exactly the same. So we didn't actually write any special code, but at least we confirmed that it works. So let's write some code that actually makes it look different. So this, whenever I call this, it's not really important. It's just calling, it's just a nice way to trigger these code hits. I just use it all the time. So let's set cursor. Actually, so we have to create a new graphics 2D object. Let's call it G2 equals graphics 2D. So I'm going to explain this line of code later, or right now after I finish writing it. AWT. So this method passes in a graphics object. This is an object that Java uses while drawing your code, while drawing your JPanel. But we're casting it to a graphics 2D object. So graphics is also it has graphics 2D like as a parent. But there are some methods available on graphics 2D that we want to use, and we cannot use them as a simple graphics object. So we're going to cast it to a graphics 2D object so that we can use these methods. And some of these methods include set color. So we're going to paint some stuff, and in order to do that, we need to first tell the game what color are we going to use. And I'm going to draw a circle, oval. Let's draw it at 200 by 200 by 200 by 200. And so if we run this now, we drew a circle on the screen. Isn't that crazy?
Yeah.
Let's move on. So we just finished figuring out how to draw stuff to the screen. Now the challenge is, how do we animate stuff on the screen? Because we don't want to be drawing the same thing for the entire game. We want it to change based on what's going on in the game. So I'm going to turn off the projector and draw stuff on the board to explain how we're going to do this next part. So I think most of you are pretty familiar with how animation in general works. What you have is a series of frames. And like, say if you had a ball on one thing, you can create the illusion of an animation by having each frame be something different. And so the way animation works is that you play these frames back to the user in rapid succession. And the speed at which you play something at is called the frame rate. Frame rate. And so if you ever like hear people talking about games, they might talk about like, oh, this game is running at 30 frames per second or 60 frames per second. We're going to make our game run at 30 frames per second. That's because not everyone has like a super powerful computer. And 30 frames per second is pretty good. It's a standard, basically. And so now the question is, how do we get our computer to make all of these frames and then show them back to the user pretty quickly? And what we're basically doing is, well, we drew the frame using programming. We wrote some code that said, I want a circle to be in that spot. And then what we're going to have to do is make our code draw the next frame. I want a circle to be in this other spot, a little bit different from the previous spot. And do it again, and again, and again. And we're basically going to have to figure out, how can we do this for an infinite number of frames, basically? Because what if the user is playing your game for a really long time? You can't just make all of these frames up front. And you also want it to depend on what the user is doing. So you can't really make them up front, or else that won't be a game anymore. So what we're gonna do, we're gonna make something called a game loop, which I'm gonna draw over here. Notice how it's beyond the projector. Game loop. So the game loop is a very common concept in game programming. Pretty much almost every game will have one. The purpose of the game loop is that we're going to have a bunch of code that runs every single frame, and we're going to call our game loop 30 frames per second. And so when you go through your game loop in one iteration, when you run through all of that code, that's going to be one frame. And then when you run it again, that's going to be the next frame. And what we're going to do is we're going to generate each frame on the fly. So when it's time to show the next frame, we're going to run our code to generate it, and then it's going to appear on the screen. And that's how it works. So there are several things that your game will do in the game loop, but right now we're just going to focus on the last step, which is update screen. So we want our screen to get updated with the latest frame that the user needs to see, and that's what that's all we're worrying about right now. Now the question is, how do we make our game loop in Java? It's not like there's a game loop thing that we can call like a while loop or a for loop. Actually, we could use a while loop or a for loop, but that would be horrible because we're basically going to make this while true, and then keep going forever and ever and ever. And if you actually do this, you're going to end up with an infinite loop, of course, but your screen might never actually draw. It's just you're gonna tell the screen to draw, but then you're gonna come back and start making the next screen, and it's never gonna really get a chance to update. So we don't want to do that, and that's also not very good practice either. So what we're gonna do, there are actually several ways to make a game loop work, but the approach that we're gonna go with, we're gonna create a timer. So there is a timer object in Java. What a timer does, it's like a stopwatch. You tell it to start, and then it starts ticking. And on every tick, it will trigger your code for you. And so we can make our timer trigger our game loop on every tick. And now the only thing the timer needs is to tell how long do we need to wait until we tick again. So it's going to ask that for that time in milliseconds. So if we want to run our game in 30 frames per second, how many seconds do we need to wait in between each frame to get 30 frames per second? 1/30th? So if you remember, like in physics, you can think of frequency as being 30 frames per second. Our period will be 1 over the frequency, which is 1 over 30 seconds. And this is about, what, 13 milliseconds?
33.
33, so it's not 13? That's true, it's 33, I remember now. It doesn't really matter, we can just write code to calculate whatever 130 is, 1 over 30. Awesome, so does everyone understand what we're doing with the game loop now? We're gonna make a timer that ticks every 33 milliseconds, and it's gonna trigger this thing called the game loop. And right now, all our game loop is going to do is draw the screen. Let's do it. We look at the code that we wrote so far. We have our Jframe, dodge the thing, JPanel. We created a JPanel. Now the question is, where do we put our game loop? Well, I'm just going to we need to create a timer, and then the timer is going to take in an object, and that object is going to be our game loop. So let's create our game loop. New class. There's several ways to create a new class. You could go up here, or you could right-click anywhere here. So let's call this class game loop. I think it extends action listener. Create a class. No, that might not be it. So I'm gonna remind myself how to do this. See, not everyone remembers how to do everything. It implements action listener, of course. So implements. So what is this implements thing, listener? So I don't remember if in 127A or 227 they teach you about interfaces yet, but an interface is basically a fancy object-oriented thing that tells you what methods to write. So we basically need to write all this code. I did it using shortcuts because Eclipse will tell you what errors you have, and it'll fix those errors for you if you roll over the squiggly lines. So what this is, Action Listener is an interface. It basically tells the other code that it says that we have this function, this method in our class guaranteed. And when we call our timer, we're going to tell our timer, please trigger this method in our game loop, please. And that's why we are implementing ActionInsert, so that our timer will know that we have this method, guaranteed, no matter what kind of class we are. Awesome. So for now, let's not really do anything except prove that our game loop is working. So we're just gonna print hello. We're gonna print this 30 frames per second, just to prove that our game loop is working. Okay, so we're gonna add our timer to the Dodge the Things class. I'll just leave a big view, it's nicer to read. So let's create our timer. So let's create a timer. Let's do it after this important stuff, just to keep ourselves organized. Game loop timer. So first of all, let's create our game loop. We're gonna need it. Game loop, GL, new game loop. I'll scroll up so that you guys can see. Game loop. Awesome. Now we need to create our timer. Timer equals new timer. Let's import it. So when you're importing your timer, there are 3 different timer classes that you can pick. Please pick the Java x.swing timer. The other ones do not do what you think they do. This is what we need to write. We need to write this import into the top of our class. Got it. So now that we created a timer, it takes in a bunch of parameters at arguments. So it takes in 2 arguments. The first one is debug close operation. First one's an integer, which is how much time it takes. So let's give it 33 milliseconds, or we could also do 1/30, because that's the period. And then this one is taking in the object, the game loop object.
Livio,
Yep.
aren't 1 and 30 integers?
Yeah.
Yeah.
Then 1 divided by
That's
30
true.
integers is
0.
So it's gonna be like times, yeah.
You can
Fine,
just
let's
put
do 33.
You could have just done like a D or an F.
I could also do like double.
And then multiply by.
Period equals 1.0 30.0 times, is it 1,000?
Yeah, times 1,000.
Yep. So this is going to give us 1/30 seconds, but we want milliseconds, and there are 1,000 milliseconds in a second. So that's what we have. So we do period, and we have to cast it to an int. I forgot how to cast. See, we're just making things more complicated to confuse you. Okay. Math. And this is basically 33. All this code just to calculate a precise definition of 33. But this is actually useful because if you make a game, you can create like a frame rate variable, frame rate. Let's say it's 30. And then here we can just pass in frame rate. And this is basically converts frame rate to period in milliseconds. Set our frame rate. This creates our timer, which triggers the game loop. There's one last step that we need to do before we can test this. We have to actually start our timer. So it's like a stopwatch. It won't do anything until you tell it to start. Okay, so let's run this and see what happens. We're printing hello world, 30 frames per second. Our game loop works. Yeah, now we have to actually make it draw stuff 30 frames per second. So how do we do that? Here's our canvas, game loop, dots and things.
There we go.
Okay. So our game loop is basically gonna have to somehow tell our canvas what to do. And right now our game loop just doesn't have a reference to the canvas object. So we're gonna have to pass it in. So one thing that we could do is we have a reference to canvas up here, and when we create our game loop here, we can just pass it in as an argument, canvas. And what that means is we're going to have to create a constructor here. So public game loop, and our constructor is going to have one argument, canvas. My canvas. So the reason that we don't need to build our constructor earlier is because our class will already have a default constructor that Java puts in for us. But now that we actually want to write custom code in our constructor, we can actually define it now. And this custom code is basically saying, game loop, please remember that you have a canvas. So let's create an instance variable, private, canvas, canvas, canvas equals my canvas. And so just to recap what we did, we went into the dodge the things file, and we added the canvas object as a value in one of the parameters when we create our game loop object. And then we created our constructor to actually take in that object and then store it in an instance variable so that we could remember it. And now instead of printing hello world at 30 frames per second, we can tell our canvas to repaint itself. So there's a lot of drawing and painting analogies when you're dealing with graphics in programming. Repaint basically tells the canvas to say, hey, we want you to draw yourself again. Please call the method that we made in canvas that calls out the graphics properties. Please do that again for us. So I'm going to write a column here saying, this is our game loop.
This is our game loop.
This is our game loop. And right now it's only doing one thing, and it's updating the screen. And so if I run it, it's updating the screen 30 frames per second, but we have no idea because nothing's changing. And we'll talk about how to change it later, but I'm going to wait for people to catch up because I see you guys are still ready. Now the next, we figured out how to draw our screen at 30 frames per second. Now how do we actually change our screen every frame so that it actually looks like an animation? So what our graphics object, canvas object is going to have to do is it's going to have to remember some things about the previous frame in order to be able to draw it better, or to slightly change what's going on. So here we have a ball. And we have a lot of data about the ball. And say we want to just animate the ball to go down the screen as if it's falling. So something that we could do is basically change this y value here. So this is x, y, width, and height. We could just change this y value to be 201 frame, 201 the next frame, 202 the next frame, 3, 4, 5, etc. Now how are we going to do this programmatically? We'll have to store the value of the previous frame in a variable. So let's write a new variable called old y. And we're going to make it 200. And then here, we're going to use that value. And so now nothing should change. All we did was put this value in a variable. But what if here, at the end of our drawing method, we did old y plus plus. So we incremented. So every frame, old y gets bigger and bigger and bigger. And so if we run our code now, it's moving. It's a pink sunset. We made an animation. Isn't that amazing? I can run it again if you want to see it again. Instant replay. So we're moving on. We figured out how to make our animation work. But what if instead of incrementing it by 1, we did old y plus equals 2? What if we made it move down twice as fast? Faster. What if it was 10?
What if it's 10,000?
Whoa. What if it's 100? It's gone. It's just zooming way past down the screen. So now what we want to do is make this respond to interactivity. We want the player to be able to push a button and control whether or not the ball is moving up or down. So we're going to refactor our code because right now it's very crude and all we're doing is drawing a circle and filling it up, moving it down. But we want to do more complicated things. Like when we change our, when we start to add event listeners to listen to keyboard events and move the ball around, we're going to do more than just change old Y. We're going to change the X. And we don't really want the canvas to be remembering this. It's not the canvas's job to know where the ball is. The canvas only wants to know how to draw it. So why don't we just create a new object or a new class called ball. And then this ball will have all the information it needs, the X, the Y, the width, the height. And then then we can give that ball to canvas and canvas can say, let me draw this ball for you. And then when we listen to keyboard events, we'll have our keyboard events change the values of ball, and we don't even have to update, we don't have to tell canvas what's going on. Canvas will just get the new data. So let's close this. Let's create our new class. New class, ball. The ball class. And this class is basically going to be the player. This is the player. The player is going to be a moving ball. So what do? We want our class to store a bunch of data. So let's create an int X.
Classes are always kept.
Private int Y. Private int. We want let's give it a radius. So this basically defines the circle. It's got a position, which is by X and Y position, and it's got a radius, which is how big the circle is. Now let's create our constructor, public ball. And let's make our constructor take in my X, or actually int my X, int my Y, int my radius. So when we create a new ball, we're going to tell it right away what X should it be at, what Y should it be at, and how big should it be. And we're just going to store this data into the class. Oops. So Y equals my Y, radius equals my radius, radius. Oh, we should also give it, we'll do it later. So now that we created our ball class, let's update our game loop. So let's say we want our game loop to keep track of our ball, because this game loop is the heart of our game. It shouldn't be the canvas's job to keep track of the ball. So let's create a thing in our game loop, private ball. Let's call him player, or her, ball player. Then when we create our game loop in our constructor, we can initialize the player as well. Player equals new ball. And where should we put him or her?
0, 0.
0, 0. Where is 0, 0 on the screen? It's going to be the top left corner, like way up here. Well, actually, when we make our little window, it's going to be the top left corner of the window. I kind of want them to be in the middle. So let's just guess and put like 200 by 200. Okay.
Don't you need a radius?
Yep. We need our last argument, which is how big our player should be. Let's make it 50.
600.
We don't want our player to take up the whole screen, unless we're making a game that's about that. So now that we have our player, we need to tell our canvas how to draw the player. So let's first get rid of this, because we're refactoring code. We're deleting code that we don't need. We don't want to move the circle anymore. But we want the canvas to be able to have a reference to this object called player. So private ball player. But we need to figure out how do we set this reference. So we need to tell the game loop to somehow pass the reference to the player object into the canvas object. So let's make a method for that. let's make a method called public. It needs to be public, or else GameLoop won't be able to call it. Public set the player. And it's gonna be void. Sorry. Set the player, and it takes in a ball object called player. Player equals P. So we can actually write our method right now. I mean, call the method right now. So canvas dot set player equals player. So we're still refactoring our canvas object. We're passing in a player, and we already did that in the game loop. When we created a new player object, we set the player just so that I closed canvas. Just so that canvas will have a reference to him or her, and then we will. We need to start actually using this player. So just for security, not really security, but like so that we don't actually cause an error. Let's make sure our player object is not null. Not null. Oops. Did I actually write that? Okay. And the reason this is important is because we are passing in the player object after this canvas is created. And so it's very likely that this method will be called by Java at some point before we actually define player. And we don't want to start using player when it's null. So this is just making sure that we're not going to cause any errors. So now we can replace all of the methods in here with to get the data from the player. So player.x. Actually, we have no way of getting the data, because if we go to player, if we go to our ball object, all of this data is private. So we could make it public so that it could access it, but it's not good practice. The best practice in Java is to actually keep your data private, but then create getter and setter methods. So basically, we could create a public method to say getX, and then a public method to set the X. This is just good general practice for when you're programming in Java. And we could do the same for Y.
And how exactly are you doing that, Livio?
So I'm magically writing the code with my mind. But so when you roll over, you see one of the little hints on the little warning. So the yellow squiggly lines underneath your code, that's a warning. It means it's not an error. But you can create a getter and setter for this. And when you click that, it's going to open this dialog box, and it's going to say, we're going to create this code for you, and it's going to have this name. And you just say okay, and it'll be good. And then it'll write your code for you. Isn't that cool? Otherwise, you can just write it yourself. But that's very time consuming and tedious. So now that we created this, our canvas has a way of getting the data. So now let's draw our thing. Player.getX. The first parameter is X. The second parameter is Y. Player.get Y. And then these other parameters are width and height. So this is a really confusing thing, because when Java wants to draw our circle, it's gonna draw. I don't know if all of you can see this from way over here, but it wants.
And do that for the other two as well.
Okay, I'm gonna draw two circles, one red and one blue. When we store our data in ball, our X and Y is going to be here at this point. This is X and Y. And then this is our radius, R. But when we tell Java to draw a circle on the screen, it's gonna set its X and Y up here. And then it's gonna ask for the width.
We have to make new instances.
And then it's gonna ask, that's actually the height.
Like right under canvas.
Yep. That's an H, by the way. And then it's gonna ask for the width.
Space.
And that's not the data that we have. We have X and Y in the middle and the radius for that. So in order to actually get the data that Java wants, which is the X and Y in the corner and the width and height, we're gonna have to do some fancy stuff. So we can basically here, we can subtract the radius. That will give us x on the far left. So player get radius minus player get radius. This is turning out to be a one long thing of code. Then here it can be our player get radius times 2. See how messy this code is? We can clean it up by refactoring, but I don't want to spend my time doing that. So now I'm going to leave this code up, but I'm also going to run the program just to show what it looks like. Okay, so we drew our thing. Now we want,
We'll do it later.
now let's actually get our circle to move based on player input. Now the next challenge is, how do we read in player input? So let's go to our game loop. And the next thing that we want to do in our game loop, I'm going to erase this because I'm trying to create a running diagram of our game loop. Right now we are updating the screen, but we want to do a next step, which is update. Yeah, let's do that. Update controls with a K. Update controls. So what we're gonna do, we're gonna ask, we're gonna try to figure out, is every single frame that our code runs, we wanna be able to ask, is this key down? Like, is the user pressing this key? Or if they're not pressing this key? And then we can do things in response to that. So right now, we need to first figure out, how do we even detect if a key is being pressed? I know if you've taken like 127 or 227, you know how to read an input from the console, like you use scanners and system.in. But because the user is pressing keys, such as the arrow keys, you can't really read that from the console. And plus, we're in a GUI, we don't have a console. So let's use this thing called a KeyListener, which is actually, Java can actually just detect, okay, you ask your computer's keyboard what keys are being pressed right now, and then it'll pass it in. So in order to create an action listener, we need to do it on our Jframe, because it's our Jframe that's going to have the reference to the listeners that we need. So we're going to have to create a new class, much in the same way that we created a game loop that responded to action listener. We're going to create a KeyManager class that will extend this thing called KeyListener. So KeyManager, or KeyMan, KeyMan. So our game loop is gonna basically go and say, hey KeyMan, is this key being held down right now? And this KeyMan needs to implement, I think, implements KeyListener. Yep. So we need to import this java.awt event.KeyListener. And then Eclipse is going to say, you have to write some methods. Okay, so we have to write all of these methods. We only really care about the KeyPress and the KeyRelease. I'm not even sure what the KeyType method does. Maybe? I don't know. I think it's both pressed and released. Like, if that counts as a type. I don't know. Questions?
What did you do to add that code quickly?
So if you got a red squiggly under KeyMan, if you keep your mouse over it long enough, you can click on add unimplemented methods. So nice. We don't have to waste our time writing code. Okay, so now we need to figure out how can we actually get KeyMan to actually listen to keys. So if we go back to our Jframe, which is where we need to do our thing, we can put code here in between before we create our thing. Oh, look at that. I'll erase this. KeyMan measure. Okay, so let's create a new KeyMan. KeyMan.
Go to adoption thing.
New KeyMan. Then what we need to do is add add KeyListener, and then we pass in KeyMan. Awesome. So this is the code that we add to our Jframe, and when we go back to KeyMan, we can test to see, is KeyMan actually getting our keys? So we can, this KeyPress method, this fires every time a key goes down.
Space. KeyMan.
Every time a key goes down. Then this one fires
Equals. New.
every time a key goes up. So if the user lets go, or if the user lets go of a key. And so let's just pay attention to this for now. System.out. .print. Let's test to make sure this works. So just to recap, in our Jframe, which is the dodge the things file, we created a KeyMan and we passed him into the add KeyListener method. Now I'm going to run, and you see nothing's happening, but if I actually press a key, KeyMan says hi. And then, so I'm pressing the arrow keys right now. I can also press spacebar. Any key will trigger this function. So now we need to wonder, how do we actually figure out which key the user is pressing? So when we call, this method gets called, it passes in this argument. This is a key event object, which has a bunch of data about the event that was just fired. And this object has a property called get key code. And so every key on your keyboard has a key code associated to it. And it's usually like a number, but we don't even have to worry about it because we can just call key event.
And then control shift.
If, so let's say if the key event
saves all.
dot dk down.
Then try running it.
VK is standing for virtual keyboard?
Oh, I never thought about that. Maybe it does. So this if statement is basically testing, is the down arrow key being pressed? And if it is, then we need to actually figure out how to tell the game loop what's going on. So let's store data about this. Let's make a private instance variable. It's a Boolean, and it's called down arrow. And this Boolean will basically say true or false. If the down arrow is being pressed down, if the user is holding that key down, then it should be true. If the user ever lets go, then the next time we look at down arrow, it should be false. So here, down arrow, true, means the user is pressing that button. So in the key release, we also need to pay attention to when a key gets let go so that we can update it. So the next thing we need to do is figure out how to let the game loop know that this down arrow is being pressed or not. And right now it's private, which means it doesn't have access to it. So let's make some automatic getters and setters for it. All I want to do is really make a getter, but oh well. And then we can delete the setter because we don't need it. It doesn't make any sense for the game loop to tell KeyMan to start lying about what key is being pressed. So down arrow. No, why did it change?
Yeah. So yeah, you can type that in. It's gonna complain at you first.
So when I added the getters and setters, Eclipse also changed everything to use those getters and setters for some reason. Yeah, it's not true. Okay, now we're good. So we added a getter. Is down arrow.
Okay, first let's drop
Down arrow equals false, right?
Now if we go back to our game loop, this is the update screen section of our game loop. Now we're going to add a new section called update controls. And what we're going to do is first of all, our game loop needs to get a reference to KeyMan. How are we going to call it KeyMan if we don't know where he is? So if we look back at our JPanel, our dog.thing class, we create KeyMan here, and then we create our game loop down here. So we can just pass him in, KeyMan. Then we go back to our game loop method, and in our constructor add a new argument for KeyMan. KeyMan,
key down, or wait, down arrow, sorry.
private, KeyMan.
Actually,
So does everyone know what we did?
I know what
We,
it is.
just like when we were adding a reference to Canvas, we added a reference to KeyMan.
Actually, if you go.
And now we need to
to
update, go back here and make sure this works.
Set it.
I think we just need to save everything.
You want to
Yeah.
set down arrow equals false. Face key
Now let's actually update our controls. Now we can do what we wanted to do all along, and it's just to ask KeyMan, hey KeyMan, is the down arrow currently being pressed? And he'll say sure, and we'll write this code over here. The player wants to go down. Go down. And so what do we do when the player wants to go down? Remember we went through all this trouble just to make this ball object. So we can actually move the ball down by typing in player set y,
See where it has where it's.
and then we can actually move it down by getting player again get y plus 5 or something. So we wrote all this code here.
A comma. Yeah, comma, then KeyMan with a lowercase.
Now if I actually run this, and I get it out of the way of the code, when I press the down arrow, it moves. But I can't go back up. Oh no.
Maybe.
Control function is allowed.
Yeah. Canvas
So now we can figure out, now that we know how to do this, we can start writing more code to say, first of all, let's have KeyMan keep track of all the other keys that we want to write. So this is going to take a while. We have 4 keys that we want to keep track of. We want to go up, down, and left, and right. So let's make those 4 variables up here. Private Boolean, up arrow, private Boolean, left arrow, private Boolean, right arrow. Now let's create the getters and setters for all of them just to save ourselves time. Getters and setters. And now let's refactor the way we handle this, because otherwise we're just going to have a ton of if statements. Let's use the switch statement for this. So here we're going to put our key code into that switch statement.
Oh, of course.
We're going to do the case thing. So this is the down arrow case. Break. Oops. Refactoring. So now let's add the other arrows. Key up, up. I like to document which case handles which key, just because this isn't always clear. It sometimes is, but when I work in other languages, sometimes it's not. Right. This is so tedious. Type like the wind. Left. Left. now we're tracking every key, all of the 4 keys that we're using. But we also need to update our other methods. Oops. So I'm going to copy all of this code, and I'm going to paste it into the key release method, because we need to keep track of when the player stops pushing these buttons. And I'm going to change everything to false. Down here. Awesome. We also have a bunch of getters and setters down there that we auto-generated. So I want to refactor our code again. A good practice with game loops is to, instead of having one big method with comments separating it, it's good to divide everything into several methods. So I'm going to hide this. So I go to game loop, cut. So I'm going to create a new method called update keys, update controls. So I removed that with all the code by cutting it. I didn't delete it, I cut it. I'm going to make it private void update controls. And you see here, I moved all of the code into this new method. And I'm going to make a new one called private void update screen. And if I go up here, copy that, and type in update screen, and paste it there, all of a sudden our code is much easier to read. So this is our game loop, and so far it updates the controls and then it updates the screen. And when we update the controls, we have a certain move speed that we want to move by, and then we check if down arrow is being pressed. Player. Move the player down. Okay. Now let's actually make it check for all the other keys. So if up arrow, then instead of adding the move speed, we can subtract it, which means the Y value will start to decrease. And the Y value is really, if 0, 0 is on the top left, then decreasing the Y value will make it move up. Now we can copy and paste and do is left arrow. And here we're going to set the X. And we're still going to subtract the X because subtracting the X will move left. And finally, the right arrow.
Oh no.
Set of plus moves. All this
Does not work.
Right, left, up. So I'm going to leave this code up, but I'm also going to run the game. I'm going to move it here. I can move right. I can move left, up, down. In our game loop, we have a player ball. If we wanted to create an enemy, we could make private ball enemy. Then down here, we could create them.
That one might be cross-listed, yeah.
Enemy.
Yep.
We could set them somewhere else, like 20, 20. Maybe make them big and anonymous, like not 200,
No.
100. And then we need to tell our canvas to draw the enemy. So we can make a new method called setEnemy. Then we can go to our canvas. I just jumped into the canvas file. I'm going to copy this, paste, enemy. Equals P. Then the canvas needs to remember who the enemy is. Enemy. See, this is a lot of code. But basically, we did the exact same thing when we were adding the player. We created a thing in our game loop for the player, then we passed it into our canvas, and now our paint thing needs to be able to draw the enemy. So let's do that. Let's copy that. Enemy, G2. Let's make it, what color should our enemy be?
Black.
Red.
Black. Let's make it red. Because I've seen a few people with black players. We don't want that. So, no pun intended. Get radius. So we need to replace everything here. Very tedious. We could fix it with, we can make this code look cleaner if we refactored it, but we're not going to do that. So we created our player. There it is. There's the enemy.
It's the sun.
It's the other sun. And now we want the enemy to do something. This is the next part of our game loop, basically. The next part is update state. And what this update state does, draw it on board, thank you. It updates everything that's not dependent on controls. Update state. And so the enemy is one of the things that is updated without the control. So if we just want the enemy to always be moving around, we can do something like, take this, copy, int, the enemy move speed should be, since it's bigger, slower than the player, so let's set it to like 5. Enemy, copy, paste. Now if we run this, the enemy is always moving in one way. Now if we copy this and make him move the Y way as well, where do you think it's going to go? Diagonally. Oh no! And now we can also add, let's add collisions. Well, we can make the enemy stay in the screen by doing if. Let's just hurry up since we're running out of time. So let's do collisions now. So the last part of the game loop is to check collisions. Check collisions. So these are the 4 main parts of the game loop, basically. And after you update state, public, private, void, update collisions. So now we need to figure out, how do we detect when these circles are touching each other? So say we have a circle here and a circle here. And they're obviously colliding. And just for reference, I'm going to draw a circle here, a circle here that's not colliding, and maybe, so this is like a weird comic strip, maybe a circle that's just barely touching itself. So we have, I want to use different colors, blue. So we have this, we know this, and this. So we have this X and Y. But we also know the other one, which is this legible? Okay. And the final thing that we also know is the distance between the 2 x's. So let's call it D. So we can calculate the distance between the centers of the circle by using the Pythagorean theorem. So we can measure the difference in x and the difference in y and figure out what this D is. So x squared plus y squared, D squared. Okay. And one thing that you can notice while looking at this problem is that this distance, this is the radius of the green circle, plus this distance, whoops, that's not the radius of the blue circle. This is the radius of the blue circle. That distance, if we add the radius of one circle and the radius of the other circle, that radius, if the summation is bigger than the distance between the points, then they're colliding. But in this case, this distance and this distance is less, the sum of that is less than this distance. So they're not colliding. And here, just to really nail it home, they would be equal distances. So So basically our algorithm for detecting collisions between circles is to say, let's measure the distance between the two center points. Let's also get the sum of their two radiuses. And if the sum of the radius is bigger than the distance between the circles, then we must have a collision. Got it? That's our algorithm. Awesome. So update collisions. We have two things that we want to check collisions with. We have enemy and ball, or player, which is the ball. They're both balls. We can, instead of writing the code here, it's good object-oriented design to write the code in the ball class. So let's do that. Let's write a new method called public boolean. It's going to return true or false. It's going to return true is colliding with another ball. So it will return true if this ball is colliding with the other ball, and it's going to return false if this ball is not colliding with the other ball. So let's figure out how to do this. We first have to measure the distance and also the sum of the radiuses. So I'm going to just get the sum first. Sum of radii, or radii. Sum of r equals other dot radius plus this dot radius. Now we needed the sum of we just need the distance between the 2 points. So the difference in x is other dot x minus this dot x. And then the same thing for y. And we can get the distance by using math.square root of diff x squared plus diff y squared. And now this is giving me an error because I need to cast it. So this is just a Java thing. This returns a double, which is like a decimal number, and we're storing it in an int. Why don't we just store this as a double? That way we don't have to lose data. Okay, now let's do the final check. If the distance is less than the sum of the sum of the radiuses, then that means we are colliding, right? Otherwise, we're not colliding. So let's see if this works. If player is colliding with the enemy, then let's print something out to the screen. Print line. Collided. Now let's test it. There's an error. Where's the error? There it is. Check collisions. Update collisions. Oh, sorry. But see, it's working. They're colliding. Now they are. Now they're not. Now we can actually make something happen when you hit the other player. You can make it so that the player dies. So how would you make the player die? Well, first of all, you need to keep track of whether or not the player is alive and do different things whether or not they are alive. So let's just store a very crude way of doing it. So Boolean is dead. And this is going to be false because the player is not dead when you start playing. Now in here we could do something. If I'm not dead, then run the game loop. If I am dead, so some print line, you dead? And let's try it. Oh, wait, it's not working. Why isn't it working? I think you know why.
Yeah.
Because I didn't actually do anything. Is dead is equal to true. Now it should work. You dead? it's printing it out at 30 frames per second. Because you just can't forget that you died. And you can't undo it either. It's not updating the game loop, so it's not checking for our controls, so I can't play it. It's not updating the screen, so even if I could play it, it wouldn't show the next frame. It's not moving the ball. Yeah. That's pretty much the game that we were planning on making. We can actually make the game more complicated by having the ball turn around when it reaches the edge of the screen. And that's easy to detect. All we have to do is check if the X position is outside of the screen, like if it's greater than the width of the screen, then we could say, don't do that. Move it back to the edge of the screen. And that way when we add the speed, it'll go over, but then right in the next line of code, we can just check right away that you're not supposed to be there. And we could do the same for the enemy as well. We can have the enemy change direction when this happens. So we can change direction just by changing the move speed to a negative, which means we'll have to store it as a private variable, just so that the change happens. But yeah, that's just rambling. So yeah, that's it. That's the workshop.
Can you, are you going to upload this completed Java project to the website?
Yes, so I'm going to upload this version. I'm also going to upload the version that we finished at 3.10, just for reference, to say, this is what we had when people started leaving, this is what we had when we left today, and I also put this one, which is what we had when we were planning the workshop, in case you want to look at tons of code. Yay. Yay.